Hi there, everyone. Welcome to our webinar. I see people are still coming in, so let's give it 1 minute. Gives you the opportunity to get adjusted, maybe do a refill on your water or your coffee, and then we'll get into it. So for people who just joined, we'll give it 1 more minute and then we'll start off. There's still people entering the webinar. First and foremost, thank you for being part of this. I know you have a lot going on in your lives and I thank you for being here. I'm also fully aware that some people will watch this on demand. So to them, thank you for checking it out. I hope, we're talking in the future now, I hope most people had a good time. So I hope people watching this on demand will have a good time as well. So I guess it's 2 past the hour. Let's get started. Welcome to the webinar called Attain Actionable Insights with Varnish Controller 5.0. My name is Thijs. Yes, that's how you pronounce that. And I work for Varnish Software. I'm in fact the technical evangelist at Varnish Software. And while this is all about attaining the insights into Varnish Controller 5.0, when you boil it down to the essence, it's about what is new in Varnish Controller 5.0. So the novelties of this brand new major release. Well, brand new, you'll see it's been out since October, but it has some really exciting stuff in there. But for those who are attending and who aren't too familiar with the controller, I'd like to explain what it is. What exactly does the Varnish controller do? Well, in short, if I need to crystallize it to its bare essence, it's a control plane for Varnish. And it has a graphical user interface. You can log into it and you can manage Varnish. Now, it's not solely a graphical user interface, a standalone user interface that you install on a Varnish. No, it's a bit more complicated because the graphical user interface is just, as you can see in this diagram, is just a part of the total architecture. I'm going to zoom in for your convenience and look at some of the various components. So in essence, the controller is a process which we call the brains. Brains with a Z because we're cool kids, right? And it is the heart and the soul of the controller, makes all the decisions and stores the data in a Postgres SQL database. The communication with other parts of the setup happens asynchronously over a message queue. We're not really married to the technology, but we opted for NATS, which is a popular technology these days. And it is a sort of a publisher subscriber system where you listen to messages coming in, which allows for asynchronous communication and also, which is very important in our context, massive scalability. You can cluster Postgres, you can scale that, you can cluster the brains, you can scale that, you can cluster the message queue, and so on and so forth. But what you can see is that at the other end of the message queue sit a couple of components, primarily the Varnish nodes, Varnish instances, marked in orange, with a little piece, a tiny piece of lightweight agent software that we call the Varnish Controller agent. It's also written by us, it's written in Go, it's super fast, it's super lightweight, and again, super scalable and communicates with the message queue, which in its turn communicates with the brains. But there's more to it. It's like when we go down, you can see that at the right-hand side, there's also an API gateway communicating with this. So in fact, we're dealing with a platform that is API driven, fully API driven. And on top of that, we've built both a graphical user interface and a CLI, a command line interface for those who are familiar with that. But on the left-hand bottom side, we see the internet users, the people we're actually building all of this technology for. And they get directed to the right Varnish instance based on decisions that are made by the Varnish traffic router, which is also a component that is arguably part of the Varnish controller, but without any doubt is nicely integrated into Varnish controller. So it makes decisions and points you in the direction of the right server. So it's much more than a GUI. But the reason why we built this, primarily the GUI, is because over years and years and years, people have been asking us the question, can you please show me Varnish? What does Varnish look like? And in the old days, well, prior to the release of V1 of the controller, it was like, look, this is our system D settings, and this is how you start the Varnish D process. And once you're in, you could log into a CLI, which looks like this. And your VCL code could be deployed in such a way. It wasn't always appealing to decision makers who were looking for something more snappy. That's one reason, to be able to show Varnish to people who want to see this sleek graphical user interface, but also to make it easier to use Varnish, because the primary goal of the Varnish controller, the reason why we built it, is to facilitate the deployment of VCL code to a multitude of servers. We have clientele that has tens of or dozens of Varnish servers, and making sure that code ends up on the right machine isn't always that straightforward. Thanks to the controller, that is made a lot easier. And that is part of a larger strategy, sort of a switch in approach that we've made. And I like to use the metaphor of the automotive industry. So prior to 2021, when we released the first version of Varnish Controller, we considered ourselves, from automotive terms, an engine supplier. Varnish was the engine of many proverbial sports cars. And we sold the engine to our clientele and said, here, build your own sports car. We provide you with the fastest, most stable engine. And people were happy with that. But throughout the years, as we've built up our clientele and worked through onboarding and support, and we got to know our clients and saw a lot of similarities in these industries, which led us to actually deciding to build our own car. And that's what we're doing. The controller is an incarnation of us adding bodywork, adding interior, adding the wheels, adding whatever you need to have a fully integrated solution. And that's what the controller stands for. This is what the controller does primarily. So yes, it's about managing Varnish servers, pretty much, and about easy deployment of VCL code. Now, for those of you who don't know VCL, VCL is short for Varnish Configuration Language, and it's our own custom language that you can use to shape the behavior of the cache to your exact needs. It also plays well into the 5G and edge compute ecosystem. The controller also contains dashboards and stats and typical things you want to see as a decision maker, as an operator. What is my system doing? What is my farm of Varnish servers doing? Another thing that we've solved in there is if you have many Varnish servers and you need to remove items from the cache, how do you do this in a distributed way? And we now have both a graphical user interface and a set of API endpoints that allow you to remove very granularly content from the cache across your full farm of servers. And then finally, also a very exciting one, and it's a bit of the glue that ties it all together, integration of the Varnish traffic routing. And this leads people, and they've done it before, but now they can do it in a much more elegant way, allows people to build their own CDNs. And believe it or not, it's a big part of our business these days. A lot of companies are looking at building their own CDNs for a variety of reasons. But if you boil it down again to the essence, most of which are financial reasons. So we won't talk about that in detail. It's just assume that a lot of people are building CDNs, and we believe that the Varnish controller is an excellent tool to build that out. Now, the controller itself, we're talking about V5 now, that's presentation today, was released in October of 2022. When you look back at the release schedule, you see this timeline. V1 was released in January of 2021. So it's a relatively young product, but make no mistake, we're fully committed to it. And we have an entire division based in Karlstad, Sweden, whose sole job it is to build this. They're doing massive improvements on a weekly basis. They're scheduling releases. And for us, it's the goal, everything we build, all the new exciting features in the engine itself will also be manageable from the controller. And as you could see, it started in January of 2021, and now we're October, or when October 22 came along, we had V5. V1 and V2 primarily focused on the core mission, managing Varnish servers, knowing where they are, knowing how to reach them, and knowing how to deploy VCL code to them. V3 was primarily about dashboards and making the GUI look nice, as well as distributed cache invalidation. V4, which was released last year, was all about the integration of the traffic router, making it easy to route requests to the right Varnish nodes. And now we're going to talk about Varnish V5. What's new in Varnish V5? Well, from an aesthetic point of view, it's a minor detail, but a lot of people using it like it. There's a dark mode. I'll show that to you. If we treat this as a sort of a software suite that you can use to build your own CDN, we have a CDN widget that allows you to display all your infrastructure on a map and see some of the key consumption stats, some of the key KPIs. There's a lot more granular routing decisions that you can make now, and I'll showcase them in a demo in a couple of minutes. And of course, since this is a multi-tenant environment, people use this to make money. In fact, people like certain telcos roll this out and sell it to clients. And when it's a multi-tenant environment, You also share the hardware. So all these Varnish nodes are part of the same platform. And maybe you have clients who pay a bit more and who want their own private nodes. And that is possible ever since Varnish Controller V5. So you can have both private agents or even private routing devices. Now, a little word about the routers. The routers are there to provide you with a way to connect to the right Varnish node. They expose themselves over two interfaces. On the one hand, typically over DNS, there's a DNS server linked to it. And if you go to www, whatever your website is, it will return at that time the appropriate IP of the Varnish nodes that fits all the routing decisions. And you'll see that in a minute. But there's also an HTTP interface that allows you to, every time you request the URL, you'll be redirected to the right endpoint. And that's ideal for video. But I won't talk a lot of theory. You'll see it in the demo. And then, of course, improved debugging. So that's my 10-minute intro about what are we doing here? What are we looking for? I guess it's safe to say that it's demo time now. But I've done a lot of demos last year and the year before. And I always add this slide for safety. You'll get it. You'll understand it, right? Whatever we're doing happens live, and there is a network. The demo is run on AWS hardware right now because it's easy to spin up, easy to tear down. If anything goes wrong, sometimes it is what it is, and it's beyond my control. Now, I've done a lot of pouring to the demo gods, so I hope we've made our offerings as well. Without any further ado, I'm going to close this slide deck, and I'm going to get into it. As always, we're taking risks, but we're happy to do so. So first order of business, of course, is logging in. There we go. This is the controller. And of course, it has dashboards. Not a lot happening right now, but I have, and I'll quickly drag it into screen right now. I have a couple of K6 nodes. K6 is a load testing tool. So in a couple of minutes, I'll be generating traffic from Dublin, from California, and from Singapore to make sure that there's a healthy flow of traffic. So I'll do that in a minute, but I'll first introduce you to what I consider the key feature, which is managing Varnish servers. That's why we call it the control plane. When we go to Varnish servers, you can see my setup, the infrastructure we have. And every time it's two nodes in a specific part of the world. Two nodes in the APAC region, which is Singapore in our case, two nodes in the EU region, which is Dublin, Ireland, and two nodes in the US, more specifically on the West Coast, somewhere in California. All these nodes have an agent software that connects to the message queue. And we, in our graphical shell here, in our graphical user interface, are connected to the API gateway. And the API gateway also communicates with that same message queue. What you can do when you spin up a Varnish instance with a controller agent, you can mention what its set tags are. These are static tags. And this will help us with the deployment in just a minute. When I click, you could see the tags, you could see what capability it has, what modules it has, what deployments it has. For now, there are no deployments, but that will change in just a minute. There's some debug information that is always convenient to use, an activity log, but not a lot happening here, and statistics on how this very server is behaving. It's up for 7.5 hours. I'll shut it down after this session. There's some CPU usage, memory usage, and network consumption throughout. So let's get into it and let's actually start creating a deployment. What you need to know is that, of course, there's a tags part where you can create all these tags, and it's a multi-tenant environment, not only from a user point of view, but also from a deployment point of view. So you can have multiple domains. I already created one org1 here. You'll see that later. But what I told you in the beginning, the key feature is managing Varnish servers and making sure that VCL ends where it needs to end up. So you go to the editor and you have this nice, what you see is what you get editor with different kinds of VCL files that you can open up. And this is the bare essence. This is the essentials, right? I'll even remove this for now. So this is as simple as it gets. We are dealing with VCL 4.1 and we're going to connect to the origin server where our content is. I'm going to save this and I'm going to create a deployment now. So that allows me to go to configurations and we call this VCL groups. We'll need this for the rest of the demo. This is not new in Controller V5, but it's just easy that I walk you through it before we actually highlight those features. I'll call this Edge because we're dealing with Edge devices, Varnish servers. So those will be root deployed. So that means the hardware is completely mine. I don't need to share it with anyone, but I will make it listen on certain domains. Number one is our endpoint here, www.privatecdnvarnish.cloud. For HTTP routing purposes, I'll also add the routers, make sure our website listens on all those routers, a router in the EU, a router in the US, a router in APAC. And then we need to assign servers in our deployment. So the way I'll do that is I won't select individual servers. We'll make this a scalable thing. So I'll select the edge tag, and the edge tag matches 6 servers. So when I apply this, I can click view. And when we click view, you can see all the servers that are matching. If I were to make it more specific and say, you know what, I'm interested in the EU edge nodes, then we only have 2 nodes, 2 servers. And that would be, comes as no surprise, EUH1, EUH2. But we're going to make it broad again and make sure that all the edge nodes worldwide are available. Now you can choose how many nodes will be used. It knows that there's a maximum of 6, so we'll keep that, but we won't be picky. As long as we have 2 nodes, we're happy. We need to deploy VCL. We can create a VCL file and start typing. It has this nice, what you see is what you get editor that you've seen before, but I haven't shown you the highlighting, the syntax highlighting, and the code completion. So I would be able to type backends, default, and then start typing, but you know that we have this file already in our repository, so we can select it. We can even upload it from our local computer, but knowing that all of this is API driven, you can even use that endpoint, put it into your own build pipeline and start pushing VCLs to that endpoint, and we'll make sure it ends up on the right machine. When I select the VCL file, I'm going to go for that edge VCL, and we're ready to go, so it seems. But of course, we want to make sure that this is reachable. We don't want to be reaching individual nodes. We want a single endpoint, and we want the Varnish traffic router to do that. So what I'm going to do right now is I'm going to leave it at this. I'm going to create and deploy and edit it later, and I'm going to take you to the traffic router. So as you can see, this is happening live. We're asynchronously deploying, and we're active on 6 nodes. When we go back to our server overview, all of them are there, and we can see that everything's deployed. And when you actually click one, you can see the deployment and all the things you need to know. So let's take you to the traffic router, because part of the new features in Varnish Controller 5 are related to that. As I've said before, we have 3 routers, one in Singapore, one in Dublin, and one on the west coast of the United States. When you click it, you can see specific tags and also potentially routing rules that require checking if specific nodes are available. We don't have that now. So what we'll do instead is we'll make sure we create a routing rule on top of those routers. So we create that rule, and the default behavior is to pick a node based on its least utilized status. So these agents that we have running also look at the network interfaces that are pre-configured and know how much they consume. In the config of the agent, there's also the maximum bandwidth that your network interface can handle. So it knows in relative terms whether or not this server is overloaded or not, and it picks the least utilized one. That's the standard behavior. However, we're spreading things all over the world, so we want some geographical awareness. I can select all these strategies. These are all routing types and decision-making components. I'm going to go for GeoIP, and I want to stack it on top of that. So first, we're going to look at the IP address of the client and try to match it to a database that has the geographical locations per IP range and figure out what the closest node is. If that would fail for some reason, we fall back on the least utilized one. We're going to call this the geo routing rule. And we need to check which nodes are healthy. We're going to go and do this on the home page. So it's going to ping the homepage of every node that is a candidate here. So that will be all of our 6 nodes, and the ones that are unhealthy won't be routed to. The way we'll do this is we won't verify TLS. We'll assume they're healthy on startup. And then we need to define our check window. Like, how do we check whether or not the server is healthy and can be considered for traffic routing? Well, it should be 3 out of 8 checks. That's a bit much for this demo. So I'm going to make it 2 out of 3 checks, and I won't be checking every 5 seconds. Instead, I'll check every single second. Now, there is an interface to this. I told you there's a DNS interface and an HTTP interface. From an HTTP point of view, I'm going to enable debugging headers. We'll see those later on. And from a DNS point of view, I will heavily reduce the TTL to 2 seconds. There might still be some DNS caching from my provider, but that's beyond what I can control. So we created that routing rule. We can attach it now to our configuration. We go here, we scroll all the way down to our deployment configuration, and we can add a routing rule. and we pick our geo. We can still create a new one on the fly, but we're going to go for geo. We're going to save, deploy, and this is where the risk happens. This is where we pray to the demo gods that everything went according to plan. Now, allow me to do a little bit of a test. Let's see, this is command line stuff. Every now and then we need to access the command line. Let's see if we do a DNS check on www.privatecdn.varnish.cloud. Do we get an IP address? Indeed we do. So in fact, that works. So I can go to a browser now. This one. This is a demo application that we have, and actually start clicking it and playing the content and see if that works. So it's loading it. For some reason, this is not working. The demo gods are a bit cruel at times, but I have, oh, there we go. There we go. We have a 720p piece of video. This is how that works. We're connecting to this very server, and it's actually our www record that will get translated by the traffic router to the right IP. I was also talking about the HTTP interface, and I'm going to quickly show that one to you as well. So instead of always relying on DNS, you can actually do an HTTP call. Now, this curl command, that is how we do an HTTP call from the command line. So I'm going to call router eu.privatecdn.varnish.cloud. And I'll widen the screen a bit for your convenience, maybe clear the screen so there's more screen real estate, and do that again. Look, we're sending a request to our routing endpoint over HTTP, and it says, you know what, whatever you were looking for, I found that, because I'm the Varnish traffic router. And I noticed, and I'm located in Belgium, the city of Torhout, which is a city like 15 kilometers from where I live, is where we located you. We made that decision in 67 microseconds based on your client IP, and we're using the routing type geo IP to send you someplace. Where are we going to send you? We're going to redirect you to EU Edge 1, which is the right decision, in my opinion. And this type of redirection isn't sensitive to any DNS caching. So you can embed that into your video player, the video player you've just seen, and for every single request to a segment of the stream, you will always end up on the right machine instantly. And maybe we can do that now. Maybe we can make some slight changes in the VCL code. I want to stop the movie and take you back to the editor and start throwing stuff in there. So I have stuff in my clipboard that I'll paste in straight away. We'll be doing multiple things at the same time. So I'm pasting all this code. Maybe I should bump up the font size for you. So instead of just sending stuff to the origin and caching it, we're also going to include some logic. Let me save this for now. Called video router VCL that has logic to embed the video router on the edge, and also some purging capabilities that allow us to remove stuff from the cache. And for geo purposes, every Varnish node has an environment variable called Varnish pop, which is either EU, US, or APAC. I'm going to put that in a custom header so we can consume that. Sounds complicated. What I will show you quickly about the video router is it's all boilerplate code, but what we're trying to do is we're trying to manipulate the HTML code of our example that we've seen, and instead of serving the video locally from the same machine, we're going to embed that router endpoint. So let's see if everything works. We can press compile and select the node here. We're going to compile it in the US. And then we'll see, there were some prior tests 3 hours ago that failed, but this one 5 seconds ago works perfectly. So I guess we need to redeploy now. I'm going to go here and deploy again. And that will allow us to have all that video stuff in, and we'll be able to purge. So let's fiddle around with one of those new features. So what I'm going to do first for your convenience is I'm going to start all those tests that I was talking about. So I'm going to make sure there's traffic being sent from the EU, traffic being sent from California here, and traffic being sent from, oh, that is currently failing for some reason. The demo gods weren't too kind to me. I'll need to figure that out on the fly, but there is traffic popping through. Let's see what goes on here. Let's try to redeploy this. It's always exciting, right? Live demos. I've done a lot of them, and there were a couple where things went wrong. So something is inactive here. Yeah, something didn't go through the tests. And that's why also that check failed. So let's deploy that again. And this should be far better. We're redeploying from an inactive state to an active state, and we're deployed now to a bigger set of servers. Let's see if this one, no, this one has recovered from that. Let's scale it to 80 users, resume, and there's traffic flowing through now. Varnish is doing its thing. And what is going to happen is that on the dashboard, you will see traffic popping up. You could see the hit rate going up. You could see the requests going up. You could see all kinds of information here. You can also create custom dashboards, full dashboards, or add widgets. So you can add a widget, and I'm just going to be clever here, call this test, and add a small widget that would either be based on a tag or the name of a server, and I'm going to select all server. I'm interested in what happens on the server, or maybe even on the traffic router. Let's look at the traffic router. Let's see what happens for the domain, for all domains, and maybe do a stack chart and figure out a counter. Let's see if there is geolocation, geo hit. Are there hits in terms of geo? And yeah, figure out the timing interval, maybe do that every minute. And then plot that dashboard. And now you can see that as these tests were introduced, that all these geo matches on the traffic router went through the roof. So there's tons of stuff you can do, and you can even track down your own statistics in the VCL code and plot them in these graphs. So that's that. Let me remove that again, and let's start doing a little bit more intricate stuff. Before I get into that, I want to show you the CDN monitoring dashboard that shows you what is going on in real time. So I'm going to try boosting up the font size a bit and refreshing the screen for your convenience. And what we can see is a world map. Let's see if I can zoom out a bit again. That wasn't according to plan. There we go. We see the world map. We treat dots. A dot, and you know this by now, right? A dot in the EU, dot on the West Coast, US, dot in APAC. If I press it, you can see what's going on. This point of presence that has a bunch of nodes processes about 66 megabits per second right now. The router itself is in good shape, doesn't do a lot. And then you can see the two edge nodes that are there. One handles about 13 requests a second, and the other one was picked and handles about 1,000 requests a second. That disparity is primarily related to the fact that you pick one, and as long as it's not overloaded from a networking point of view, it can still handle more. So the majority of the traffic is being sent to edge 2. If that traffic leads to this server being saturated, then the other one will kick in as well. But that's just the EU POP. If we take you to the US POP, things are happening as well. Now, the long and the short of it is, if you sum up all these values, you'll get what's here at the bottom. At this point, we're processing 2.1 gigabits per second on our demo environment, which is not a lot, of course. Like the numbers that we've released that you can handle on a single machine is up to 500 gigabits per second. But this is just a demo environment. You can also see that we're processing about 1,900 requests a second. So this is a major feature of V5, of controller V5. It gives you a clear overview of how your infrastructure is behaving and where it is located. But let's start fiddling with it a bit. So after the second thing, let's see how that works. I am going to boost up the font size. So this is this typical trick that I apply. This is a timestamp, the current timestamp, but it doesn't change every time I refresh, which symbolizes the fact that it's cached, which is easy. Nothing really going on. But what we know is, thanks to that request header that we sent, I'll take you back here to prove my point. Thanks to this xpop header containing the value of the POP where it's served from, we know that we're in the EU. Let's change that. Let's fiddle about. We go back here. We go back to our traffic router category and pick a routing rule. And what we're going to do is we're going to edit that and create a different routing decision. So here are routing decisions, and we have different kinds of intricate routing decisions. You can create external routes. Maybe if you have a multi-CDN setup and you want to funnel some traffic to your CDN, you can do that. What I'll be doing first is doing it based on a specific geolocation. So I'm going to create a geolocation rule, and I'm going to call this Belgium because I happen to be in Belgium, so it will work best here. I'm going to pick a random server, and I'm going to make sure that this only matches when I'm in Belgium. There's a couple of Belgiums here. There's Belgium, Wisconsin in the United States, but there's the country of Belgium where I'm located. We're going to pick that. And whenever we're locating someone in Belgium, instead of following the default rules, we're going to override it and we're going to send those people to the US. I'm going to do that. So we create that decision, save it, and go back to our routing rule and stack one on top of it called geolocation. We drag it to the front. It's stacked because if one doesn't return true, then the next one could take over. So this rule is only executed if the routing decision is Belgium. Otherwise, you go to the next one, and otherwise you go to the next one. So let's save this for a minute, and let's hope that DNS caching doesn't really get into the way. What I can do is run that one again. And now we're being sent to the United States, as expected, right? Because the routing type was a geolocation route, and we've been located in Belgium, so we're being sent to the US. Let's see if DNS caching doesn't screw this up for us. So if I refresh it, we're in the United States. Let's make it even a bit more exciting. Yet another feature of the decision-making process here in the routing component that is part of the new controller is maybe do it based on a subnet. So I know what my IP address is, or at least what the range is, and I'm going to create a CIDR route. So we're going to call this Telenet. Telenet is the name of the internet provider I'm using right here in my office back home. And I'm going to select a random server if the subnet is a /24 of that range. Then I want to be sent to Asia Pacific. So you can actually override certain decisions. And you've seen it before. We'll do it again. We'll be taking you to the routing rules. We'll extend them and stack yet another one on top of that called CIDR. I'm going to go for Telenet. So if you're a Telenet client, you'll end up in Asia. If that's not the case, if you're in Belgium, you'll end up in the US, and otherwise default rules apply. I'm going to save. And let's try that again. We should be ending up in Asia. That's the conclusion. Calling the router, and indeed, as expected, the CIDR for that subnet kicked in and redirected us where we needed to get. Now, these are, of course, all debug headers that I enabled. You can disable them as well. So if you go to your routing rule, you can actually scroll all the way down to the HTTP routing bit and say, you know what? I don't really want to see any debug headers because we're exposing too much sensitive information. So when I click save and I go back and I do it all over again, you'll see far less stuff going on. So that's that. I showed you some of the new decision-making components that are part of the Varnish controller. And I also showed you the CDN monitoring already. Let's get rid of all of this. Let's remove them. And try something completely different. I'm going to remove this. And I'm going to edit my deployment. And I'm going to be very picky here. I don't want all edge servers. I'm going to edit this. I'm only interested in edge servers in the United States. So we're going to narrow it down. Only 2 servers matching. I'm going to add another configuration that only picks edge servers in Asia Pacific. So if we do our maths right, 2 + 2 is 4. A minimum of 1, a maximum of 6. Let's put this to 6 as well. We won't be having any of that. And we're going to save and deploy, which ensures that no traffic will be handled by the EU servers at this point. Because what I'm going to show you now is how these private nodes work, how we can ensure that the EU servers are not used by the full platform, by everyone on the platform, but by a specific tenant. Let me take you to Varnish servers. You can see that the EU servers have no deployment assigned to them. I'll specifically do it for EU Edge 1, just so you know. And I've been talking about tenants. So we have 2 custom tenants here, which is org1 and org2. Organization 1, organization 2. Organization 1 has a user called user 1. And if we go to accounts, we have that user 1 and user 2. And user 2 is, no surprise, associated with organization 2. So what we're going to do is, I'm going to need multiple browsers to play this game. So I'm in Chrome now as an admin. I'm going to go to Safari now and log in with org1, user1, and the appropriate password that we need to be in there. Oh, we need to refresh the page. There's security in there for CSRF tokens. See if that works. So org1, user1, and then whatever password we had. We're logging in. And if you look at the servers, you can still see all the servers. But what we're going to do, we're going to go to tokens, and we're going to create a private token, which will associate with a node. So I'm creating the private token. I'm calling this org1 private. And here it is, it's created. I can go into the details, you can see all the information, but I'm going to copy that. And I'm going to do something risky. I'm going to log into a Varnish server, more specifically. I'm going to log into EU Edge 1, and I'm going to assign that token there. Quite risky. See if it still responds. Yes, it does. So I'm going to open up the agent configuration, which also shows you a little bit of insight of what is configurable. Also, latitude and longitude is in there to locate them. Capabilities of the network interface, its base URL. So what I'm going to do is I'm going to add a line here called private token. And I'm going to add the token. Let's see if I still got it here in my clipboard. Let's copy it. There we go. That's the token. So what I'm going to do now is stop the Varnish Controller agent, which is our little agent software. Stop it, which will result if we go back into the dashboard, especially from a sysadmin point of view, it's no longer available. It's down. What we'll do is we'll remove it. We'll delete it here. And now we'll need to restart it because we turned it into a private one. So if I turn this on again with start, should be popping up again real soon. There it is. And what you also see is that it's private now. It can only be used by me as a sysadmin or by, if we're here, it's private to me as well because I'm in org1. Now I'm going to take my third browser window. I'm going to use this, refresh it again, and I'm going to log in with someone who doesn't have permissions, someone who is part of org2, whose username is user2, and also has a password. When I log in and go to servers, there's no EU Edge 1. There's not supposed to be an EU Edge 1. So what we're going to do is we're going to create a deployment for that one. So I'm going to go to the editor. There's no files here whatsoever. So let's see if I can add a new file. We call this org2.vcl, and it's pretty basic. Let's do the minimum amount of VCL that we need to do to get going. We have a backend. The backend is called default. It has a host assigned to it, which is origin.private cdn.varnish.cloud. See if this is all correct. Let's do a compile. And the compiler said that everything's according to plan. There we have it. We'll also create a config for it. I'll call it org2 as well. And we don't really have any, or I created an org1 domain here. And I am going to select all the EU edge nodes that I'm allowed to use. And in reality, that's only one, edge 2, because edge 1 belongs to organization 1. I'm going to assign the VCL file. I won't be creating a routing rule. It's not the goal for me to set up this entire deployment and deploy code. I just want to show the private aspect of it. So what we've done now is we created this setup that runs on a couple of servers, but not all of them. But if we are so kind, let's say there's an understanding between organization 1 and 2 that organization 2 can use EU Edge 1. So what we do then is, I'm in Firefox, I'm going to go to Safari, which is the management suite of organization 1. I'm going to go to tokens. And we already defined our private token, which we've linked to our agent. We're going to share a token now. So I'm going to create a shared token and call this org1 shared. And that shared token is going to be based on the private token that we've built and assigned to server 1. When I create this, it'll be there and I can share that value. It's now copied. I'm going to go back to my user for organization 2. And what I can do with tokens now is register the shared token. And something really specific will happen. And maybe not to make sure you see what is going on. So EU H2 is the only node that has the deployment. And when I click the deployment, there's only a single, when I click that deployment, there's only a single node that is selectable. It's deployed to one node. But when I share it, when I add the shared token, here we go. Now we're entitled to use that node. Again, it was originally dedicated hardware for tenant one, organization one, and now thanks to this shared key, we can use it as well. So if I go to Varnish servers, all of a sudden you see that this server is part of the game as well. I think I messed up the surprise a bit by limiting the range of deployed servers. So if I set this to 2 now and save and deploy, which should normally happen automatic if I set it to that value all along, all of a sudden, this deployment is now on 2 machines. But if you can see it here, we've just shared something. So long story short about this feature, we allow you to have both private agents, private Varnish servers, and private routers through private tokens that you register in your agent. However, if you do want to share something with another user or another tenant, you can do so by creating shared keys. And that's pretty much what I have for you today. There's one more thing that is part of the list of topics, and that is debugging. So when we would go to a Varnish node, let's say EUH1, well, we're not allowed to do this because we're in a specific tenant. So I'm going to go back to my admin user. There's a debug screen here, and there's a lot of JSON code. You can really dig into this. So if you're using this and you run into trouble, you can download debug file, send it to our support team, and we can figure out what's going on. And it's quite extensive. You can see all the deployments, deployment IDs, the VCL code, like everything is there. So if you run into trouble, the information is always there. And with that, I want to say thank you for checking this out. I did a short overview of what you can do with the controller. So yes, you can deploy VCL. You can have a farm of servers spread across the globe. And thanks to the CDN monitoring button, you can see where they're located and what type of traffic is rolling through it. But thanks to a lot of these new traffic decision-making capabilities, you can do very granular decision-making and ensure that the right requests end up on the right server. And these servers, as you've seen a minute ago, can either be public as part of the base setup, or can be very private to your organization. But due to granular controls, permissions, and multi-tenancy, you can create a shared token and ensure that someone else can use your server as well. And that's it for today. I'm going to stop sharing my screen now, and we'll see if there are questions. You can there's a specific questions and answers widget in this Zoom setup. So if you have any questions, now is the time. I want to bring it back to our holding slide. I want to thank you for being here right now, and let's see if we have any. We just seen, can we see dark mode? Someone asks. Obviously, I forgot to ask that. So yes, that goes to show that a lot of people care about the dark mode. So this is our regular light modes. When I go to my little profile button, I can go to dark, and this is what we see. The servers, it's different contrasts. So for people who enjoy dark modes, this is what it looks like. Any other questions? And if you don't have questions right now, maybe you stumble upon a question you have, please reach out to us. We're happy to answer them. We're happy to show you what we have. Then we see someone else asking a question. What about latency streaming for OTT services? Well, what you've asked there, Jeffrey, is a whole different topic. And yes, a lot of it can be covered with the controller, but it's more of a mission statement than anything else. We do want to reduce latency. And how do you reduce latency for OTT services? For those of you who aren't familiar with the term OTT, it's over the top, and it usually refers to like online video streaming. How do you reduce the latency for that? Is by putting nodes as close to the user as possible. And to some extent, we've done that, right? If you look at our CDN monitoring overview, we are able to serve consumers on the West Coast of the US, in the EU through here and in APAC. But if your plans are to reduce latency for very specific markets, you can continuously add nodes in those regions. The controller will pick that up, and we'll use I hope your question is related to that, to a routing rule that says, look, we're going to use the GeoIP and find a user that is as close as possible to where we have capabilities. If that is not the case, well, you could still do, as you've seen, these very intricate routing decisions and create exceptions. If you know that for Belgium users, it's best to point them to that very POP, or if you have a specific, maybe external route where you want to route traffic to for another CDN, that's possible. So there's nothing in there, Jeffrey, who, thank you for asking the question, by the way, about how to specifically press a button to reduce latency. Our entire mission is to reduce latency for OTT video streaming by allowing you to build your own CDN with nodes as close as possible to the consumer. So that's a long story long. Oh, and there's a follow-up question. I've noticed some routing plugins. Do you have any examples of what people are using this capability for? Unfortunately not, but what I can do as a sort of a consolation prize is show you the documentation page of the custom plugins. We showed you a whole list of things you can do in terms of decision making. If that doesn't satisfy your needs, you can even do it yourself. So let's see if there is a documentation page of a, let's look for routing plugins. These are gRPC plugins. And there's a whole, this is a dedicated page on our documentation page on Varnish Controller, routing plugins, gRPC, that explains how to create all the dependencies you need to do so. So all the code is there. And pretty much what you can do with this is you get TCP IP information about the client, you know, the domain, all the URL information, all the header information, and you can program it yourself. You can interact with whatever system you have to optimize the decision-making process and do that. And to answer your question, like what are people using this capability for? Well, it's primarily to interact with their own systems, perhaps. Maybe they are more opinionated than we are and have better decisions that can be made based on external parameters that are not part of our decision-making. Maybe they have very detailed logs or metrics that show what the best route is. So what this does is it also shows you all the endpoints, so every single node, and then based on your information, on your integration, you can say, we see that the client comes from here, we match it to our database. Oh, we believe that the best hop or the best pop is Singapore right now, let's route it to Singapore. And we will use that plugin, you can register that plugin in our graphical user interface here, register it here as a service, and then you could start using decision-making algorithms that you've designed yourself. Again, long story long. Thanks for the question, by the way. It's a really good one. Any more? If not, I would like to thank you for being here. And again, if you come up with more questions, we always want to answer them on a one-to-one basis if need be. And there's a final question coming in. We'll treat that as the final one. How does the router handle failover logic where regions go down? Well, what happens, it's all based on the routing rules here. So what I've shown you earlier is that we have various traffic routers and they each have a bunch of endpoints that they measure. Router US, www, APAC, and what have you. And this is done on every single node that matches the tags that we've registered. So the health checks allow us to know what is healthy and unhealthy. At this point, there's no unhealthy servers, everyone's running. But based on the routing rules, we can decide what happens when the routing rule is not matched. Let's say we do GeoIP-based routing, and you as a client are based in the United States, but our entire United States POP is down. So that means there is no healthy service to match this. So you would immediately go to the next one. And the next one in this case is least utilized, meaning you will no longer have geographical awareness for this request. We'll just find in whatever other pool we have of servers what the least utilized one is. And that allows you, if a region fails, to do more extension and do more customized failover behavior by adding more routing rules at the bottom, just to cater for whatever happens. But the standard behavior for GeoIP, even if I delete this one, is figure out the closest one. If there's multiple matches, get the least utilized one. If we don't match, just figure out whatever's available and pick the least utilized one. That should answer that question. And a very short one, a very A last one from someone else, the very last one, ladies and gentlemen. What happens if the controller is down? Well, nothing changes if the controller is down. It's not like your Varnish nodes will go down. This is a control plane. It has no bearing, has no impact on the runtime of Varnish itself. What will happen is the controller is a multitude of components. So let's say the brains goes down. Well, no decisions can be made, but the decisions that were last cached on the different components can be used. So whatever configuration that was deployed to all your Varnish nodes will still be in use. Whatever routing decisions that were made prior will still be there. And when the controller comes up, it can resume its tasks. So pretty much if your controller goes down, you can stop controlling it. You can stop seeing the stats and adjusting things, but everything still works with the latest information it had. All right, it's almost 5 o'clock, ladies and gentlemen. Thank you for being here. Wherever you are in the world, good morning, good afternoon, good night. For me, the day is about to end. I'm happy with you guys being here. I'm also grateful for the level of interaction that we had, and I hope you enjoyed this demo. This will be recorded. You can still watch it on demand. And again, if you have questions, do reach out to us. We're happy to help. Thank you very much. Have a pleasant day.